Okay, after we've discussed about the minimum distance as well as a parallel pivot, now we discuss with another kind of classification algorithm in supervised classifications, that is a maximum likelihood. So maximum likelihood, the computer will calculate a probability density function for every training classes. So all the pixels will be calculated through the probability and then get the density of the pixels. All right, and this will create a probability contours through the Gaussian techniques. Okay, around each class mean, and the probability of an unknown pixel which belong to each classes will be examined, and pixel will be assigned to the most likely category. Okay, so here if you try to look here, the same value of the pixel again, right? Number one here, due to the Gaussian kind of the contour, okay, the center will be the higher dense and the outer ring will be the lower dense. So any, just like a parallel, so any pixels that falls within that group will be assigned. Same concept, no doubt about this. Okay. The only limitation for this approach are that it assumes normal distribution. Okay. So the problem with this is we assume that all of the pixels are normally distributed evenly left and right. Okay. Here. So it's quite difficult, okay, because some of the pixels still remain unclassified if it falls outside. All right, and it is computationally complex because to create a density equiprobability contours through Gaussian, it requires quite some time and processing power. All right, however, okay, it can give you, if the pixel is still near to each contour, it will automatically assign because the contour will be created extended. Okay, it could be extended but not within too far range. Okay, and after this, this is how the classified image will looks like. Okay, so before you will see how the image here, this is the image that we classify, that this is the image, and after that, after you do the classification, this is how the image will looks like. You don't have to recreate classes for each chunk of the image. The computer will do it for you, and you get the overall of the land use covers of the satellite imagery. And here you can see this is the urban, this is the vegetated area, some forests, water bodies, and you have some clear ideas of, okay, all right, so this is all the urban. You can see, you can determine, you can calculate the area of the forested areas, the vegetated areas, you can calculate how big the urban is, and so on, and blah blah blah. So it will help you to understand more and more about how the area, how the land use of the areas, and how people make use of the land. Now, after this, we will go to the next subtopic, is unsupervised classification.